Welcome to your video on graphing quadratic equations in standard form. The word standard form should sound familiar. We have talked about that when we were working on factoring. And the first thing we're going to look at is what is exactly standard form for a quadratic equation. You'll notice we have y equals ax squared plus bx plus c. In the past, we've really just focused on ax squared plus bx plus c equals 0 because we were working on solving those. Now we've put the y in there because we're going to work on graphing it. So clearly we're going to need an x coordinate and a y coordinate to start putting the points on the graph. When we actually graph a quadratic equation, it makes a sort of U shape. Not quite a U, but that's probably the closest letter that it resembles. And we call it a parabola. So as I refer to the graph, you can either call it a quadratic or you can call it a parabola. Those two words are interchangeable. There is some vocabulary that you need to be familiar with when you're talking about quadratic equations. And probably the most important point on the graph of a quadratic is the vertex. This is the high point or the low point, which we refer to as a maximum or a minimum on that parabola. The vertex is just a point, so it will have an x coordinate and a y coordinate. And later on in this video, we will be showing you how to find that just by looking at the equation. Once you've figured out where the vertex is, there's an important line that goes right through the vertex, and that's called the axis of symmetry. So here, when I say it's the vertical line through the middle of the parabola, it really just means it's a vertical line through the vertex. Since the axis of symmetry is a vertical line, there is an equation for it. And if you recall back to our linear equations unit, the equation for a vertical line is just x equals a number. Now that number is actually going to come from the x coordinate of the vertex. So we'll show you how to get that. In fact, the axis of symmetry does have a formula, and that formula is x equals negative b, or the opposite of b, divided by 2a. Now those a's and those b's come right from the standard form of the equation. So the b is the number in front of the x, and the a is the number in front of the x squared. All right, the last little bit of vocabulary that we need to look at are words that you are already familiar with. X-intercepts, solutions, zeros, and roots we've talked about being used interchangeably. And those are the answers that we've been finding when we've been doing factoring and ZPP. So that's when we just set y equal to 0 and then solve. On the next slide here, we have the picture that is in your notes, and I just wanted to talk a little bit further about these points. So these are really the vocabulary words that we just went over. Let's start with the vertex, because we talked about that being the most important point on the graph here. So the vertex has coordinates, and you can see here that the vertex is a minimum. And it looks like it has an x coordinate of 1 and a y coordinate of -4. So in this case, the vertex is a min, like I said. The axis of symmetry, notice, is that dashed line. Now it kind of ends, but that's really just because the graph stops, but we know that a line does continue forever, so we could actually extend that dashed line and kind of put arrows at the end there. But it is an equation, and we did say it's x equals, and because the x coordinate of the vertex is 1, the equation for the axis of symmetry is x equals 1. So we'll label that. Looking at the x-intercepts, which we also refer to as solutions or zeros or roots, we do have 2 of them, and they can easily be seen here on the graph. The -1 over there looks like it's -1, 0. And then the other root in the positive direction is 3, 0. And if we would have the equation for that parabola, you could actually solve for that by doing our factoring and our zero product property like we've been looking at. This diagram also kind of has just a bonus little point on here, the y-intercept. Notice how it has 2 x-intercepts, but only 1 y-intercept. And every graph that we work on will only have 1 y-intercept. And the coordinates for that point would be 0, -3. All right, next we're going to take you through an example. And first, before we actually get to the graphing, I want to identify some steps for graphing a quadratic equation. So the first step is to find the axis of symmetry. And like we said at the beginning, that's x equals -b over 2a. And this step is really going to lead us to finding the x coordinate of the vertex. And remember that vertex is kind of the most important point. It's either that maximum or that minimum, kind of the turnaround point for the parabola. Once you've figured out that axis of symmetry, or the x coordinate of the vertex, you now have to find the y coordinate of the vertex. And to do that, you simply plug the x value that you found in step 1 into your equation. And we'll go through an example where we practice all of this in just a little bit. And then the third step is you are going to make a table, and that's going to look just like your XY chart, like we used to do with lines. And the most important thing that you're going to remember with the table is that you're going to put the vertex right in the middle. And by doing this, you're going to save yourself a lot of work and frustration. Okay, let's get started. Here is our example. Look at the equation that we're given and note that it is in standard form. So if you want to think about your ABCs here, the value of A would be 1, the value of B is -4, and the value of C is -5. And the first thing we want to do is go ahead and find that x coordinate of the vertex, or the axis of symmetry, by just plugging it into our little formula. So we're going to set up that equation. The opposite of B, so notice we have 2 negatives there. The negative has to be there from the formula, but then we also have to have the negative from the actual B value. Okay, we're going to figure this out here. So we've got a double negative, which is going to cancel. And on the bottom, we're going to multiply the 2 and the 1, so that's 2. And then we're going to divide it out and say that 4 over 2 is 2. Now notice we have x equals 2 because that axis of symmetry is actually the line x equals 2. So the next thing we're going to do is actually graph that line. And that's going to be the first thing that you put on your graph for the quadratic. Even though that's not actually part of the graph of the parabola, it's going to be the thing that we use to get all of the points. So what we know now is that the vertex is located somewhere on that vertical line. And we just have to figure out where by plugging our x value into our original equation. So in that equation, we're going to replace all the x's with 2 and then just simplify. And if you want, you can put this in your calculator or you can just do each step individually. So 2 squared is 4, and then -8 minus 5. And if you simplify that, you would get -9. So now we know that our vertex is at 2, -9. So that's the next point that we're going to put on our graph. And you'll notice that the axis of symmetry, that the vertex is right on that axis. Now, in your notes, I believe your graph isn't quite as big as the graph that I have here. So if your points go off of your grid a little bit, just draw them in, and that won't be a big deal. Okay, so we've done step 1 and step 2, and our last step to get the rest of the points is to make a table. The key is to put the vertex right in the middle. So we're going to put that point 2, -9 right in the center, and then we're going to choose points using symmetry. So you want to go up a little bit and down a little bit. So if we go down, we'd have the points 1 and 0. And if we go up, we'd have the points 3 and 4. Now, you only have to do half of the work for this table. We're going to really use the fact that a parabola has symmetry to help graph those other points. So let's go ahead and put a 0 in there. That's a nice, easy number to plug into our equation. So if we just talk through this here, we have 0 squared, which is 0, minus 4 times 0, which is 0. And we end up with the -5 being the only thing. So the first point there is 0, -5. And we're going to go ahead and graph that. So you would just go over 0 and down 5 to get to that point. And then notice that little vertical line there. We're going to take that point and we're going to flip it over the line. We're going to use that symmetry. So since it's 2 units from the line, the next point has to be 2 units on the other side. Well, if you look at that, that's when x is 4. So we're going to fill that in on our table without doing any work. So it's kind of nice, huh? Next, we're going to put in a 1. So if we just sub the 1 into the equation, we'd have 1 squared minus 4 times 1 minus 5. And when you simplify all of that, you would end up with a -8. So we're going to go ahead and graph that point. So we have 1, -8. And then we're again just going to flip it right over that axis of symmetry and find out that the point 2, -8 is also there. Now, this graph is starting to look like a U shape, but we want to make sure that we can also find the 0 since we've been focusing so much on doing that. So if we plug a 0 in for y, we could also factor this, just like we've been doing, and use the 0 product property to actually figure out our x-intercepts. So for this one, it looks like a simple x method. We want factors of -5 that are going to add to -4. And so our only choice is a -5 and a +1. So we would factor that. We would have x minus 5 times x minus 1, or I'm sorry, x plus 1. I was thinking ahead to our solutions here. So x equals a -5. I'm sorry, x equals a +5, and x equals a -1. So if we were to just add another couple of values onto our table here, we know that when the x coordinate is 5, the y coordinate is 0. And we know that when the x coordinate is -1, if we just kind of squeeze that on the top there, that the y coordinate is 0. And so now, by filling those points in on the graph, you can see that those points are already there. We get a much better view of how wide our parabola is going to get. Now, these are somewhat tricky to draw, especially on a smartboard. But you want to make sure that you get that smooth curve. They should definitely look more like a U shape on the bottom, and they shouldn't be these pointy things that start to look like lines. All right, so there's a lot going on here. We're going to need to do a lot of practice with this. If you have any questions, just see your teacher. Otherwise, you are ready to start your practice on graphing using standard form.